the kind of plant he's starting up is something that's in our wheelhouse.
Yeah, and you know, that's what's been very interesting with the commissioning startup. So I've typically been on the owner operator side, and you know, I've also been on the contractor side with a company that we started up. And most of the time, you know, we end up being hired by the owner operators. There has been one startup I was involved in when it was actually with the construction contractors, but it gets kind of weird because when we're getting ready to do the final commissioning and startup, I'm usually in the control room. I'm with the operators. You know, so sometimes there can be a little bit of a tension, you know, with the EPC contractor because they feel like, well, you know, we hired you. You know, we have an office for you down here in the construction trailer. Where are you at? But you know, they quickly see the benefit of that, you know, talking with the operators and making sure everybody is lined up. So that's exactly what I'm going to be talking about, and really that importance, the communication side of it. All right, so I want to talk about is eliminating the gap between the EPC contractors and owners operators in the commissioning and startup side. And what I want to focus in is on the components of having a successful commissioning and startup. And then I'll give examples of what good looks like and what we try to drive to have these successful commissioning and startups. You know, what are the things that are going to close this gap? And really the two main things that I really want to drive home for closing that gap is early design feedback, and really the importance of defining the who, the how, and the when. When those are defined, you have a very good streamlined startup. You have what I would call, it's important for somebody like myself, you know, with Anvil as a commissioning manager, we're going to own that. We're going to own what we've defined there at the who, the how, and the when we start doing the execute work. But doing the upfront work is very important. Right. Sorry about that. Okay. So, so what do we provide that's going to close the gap between this? So we have the experience and alignment. Those are the two things that are what we're bridging when we bridge this gap. And the gap is the communication and what is required to have a successful commissioning and startup. So what is very important is having the uniquely experienced people. So oftentimes what you'll see people that may be a discipline engineer. They're going to provide, okay, this is how this design's supposed to work. And then you'll have the project manager, you know, somebody that has good project management experience. And then you'll bring in somebody that has a strong operations background. Well, what we provide, like somebody like myself, is okay. I'm the process engineer. I have the technical background. I also have extensive project management and an operations background. I've actually served as a board operator. I'm certified as a board operator. So that's what makes it unique. So like for this startup I'm in right now, it's just me, you know, and this is over $100 million facility that has a lot of unit operations that all these pieces and components have to be brought together to have this startup. The other thing is the frontlines experience, like I mentioned before, and not only having that frontline experience, you know, it's not somebody so much that maybe has 26 years of experience that is sitting at a plant that's been silently running and they may have a few turnarounds or small outages. It's actually having the experience with greenfield startups, you know, startups where this plant was just built, this facility was just built, and you've been able to start up, you know what it takes, right? It's kind of like saying you pretty much have seen it all. I mean, I use that term loosely. I learned new things, you know, in every one of these startups. But what's really important is, say you have a lot of experience in starting up recip compressors. You know exactly what it's going to take for you to commission and start it up. It's not so much you just start this equipment up. You have to do the hot alignment. You have to do different work like that. And with that experience, we can bring in the alignment. So there's the alignment piece. What's really critical for the alignment is getting a proven process plan for that commissioning startup And we like to do it as early as possible. And late select is not too early, right? Or start looking at it early in the define or in the design phase. So we definitely want to have an idea of the equipment that's involved and a plan early on. The earlier the better. And I'll talk about that and I'll give an example of how this is important. The next thing is we need to define the who, the how, and the when for commissioning and startup, right? And once we have that plan, which we really want to be doing prior to us executing the commissioning and startup. But once we have that plan, we own it and then we execute it. And the other thing, and this is where I've seen all kinds of commissioning and startup fall apart, right? You got to have the ongoing collaboration. You have to have the open dialogue between the contractors and the operators, or I should say the operator owners. It sounds really simple. We talk about it all the time, but unless you're having daily meetings or you're interacting on site between two groups, it's not going to happen on its own. So it's very important, and that's like I said, where you got to have that project management experience. Got to know how to talk to operators. Okay, so the early design, like I said, we want to look at the new design build. We want to review it and provide feedback, and we're reviewing it not so much from saying, okay, let me see your material and energy balance. Let me make sure you've sized all these pumps and control valves correctly. Most of the time, I don't give you the benefit of the doubt unless something looks really off from what I've seen before. But what we're looking at is we're looking at it from a startup standpoint, right? Um, a cold start. Now there could be facilities where it's just an addition, brownfield, but you still want to look at it from the standpoint of, okay, on a high level, what is it going to take to start this up? Usually you're going to be saying, oh, I might need a startup line. This is going to be a line that's normally closed. It's only used for startup. It really hurts you if they're missing utility requirements and availability. So if I have, say, a recip compressor that's running off of fuel gas, but if it requires the plant to be started up and it's providing its own fuel gas, I have to have some way to, say, buy back the fuel gas. I have to have means to have those utilities and how available they are. The startup modes of operation. Sometimes when you're starting up, you're going to be bringing equipment up, you're going to be shutting it down, you have to do hot alignments. So you're not going to have your full flows usually initially. Also, you might be operating at lower temperatures and pressures, so you got to be mindful of that. Startup filters, we really like to filter our liquid lines, and if we don't have filters in that line, we might be putting witches hats in there, or we might be providing valves to bring in temporary filters to start filtering out these lines and cleaning them up. Define stage. This is, again, we're getting more into the details at this point. So we're going to be checking all the equipment, the piping, and the controls. There may be different startup modes. There might be low pressure and high pressure interlocks that we're going to have to bypass, in order to be able to come up at lower pressures. Say, like, for example, for this plant, we have to do dry outs at low pressures. Biggest headache I always see is, give us appropriately sized vents and fill lines. I'm trying to fill 7,000 gallons of amine, and I have a 1-inch line, or a 1-inch valve in order to fill it. The other big one is purging requirements. So if I'm initially purging with nitrogen and then bringing in fuel gas to purge it, how easy is it to be able to purge this equipment? I don't want to be connecting hoses at one end of the plant, disconnecting them, lining them up somewhere else. Let's make sure we can get everything purged, hooking up in one location, and being able to sweep all the equipment, sweep the air out, sweep the nitrogen out. So there's things we typically see that have been missed that we have to look at. So one example of a recent startup here was for a cryo plant dry out. So when we were doing a cryo plant dry out, the EPC contractor had designed, spent a lot of money in order to take these reciprocating compressors that were going to be flowing. They're the ones that are going to be moving the flow for the dry out. And these things were typically second stage. And they said, okay, well, we don't want to be building up really high pressure when we're drying out, because we're not going to be JTing across valves. The whole point of this dry out is to remove moisture. By JT gas, I'm going to get too cold. I'm going to start freezing up my lines. Really good idea to be able to one stage these recip compressors. But the issue was that part of the unit required us to use a single stage centrifugal compressor in order to run these through these MOSIV beds. So when the MOSIV beds had to be regenerated, what we found was, and we found this before we started up because it was the first thing I checked when I was on site, was it was supposed to be operating at a pressure of 450 pounds. The normal operating pressure is 950 pounds. So again, dry out, low pressure, and the operating procedures for the dry out that we received said, okay, we can operate anything at a lower pressure at 450. Looked at the compressor curve, and I found out very quickly that no, we could not run at that low of a pressure because the centrifugal pressure couldn't keep up. We needed 9 million standard cubic feet a day through it. So we had to actually pressure up the front end of the plant to 775 pounds. That brought issues because we did start the JT at that point. So we had to actually modify our dry out sequence from what was planned, and actually reverse flow through some of these lines so that we can maintain warm temperatures in the part of the cryogenic plant that we were drying out. So again, getting that feedback early is important.
So Mike, you're saying that you could identify that issue with a desktop exercise in advance of
Yes.
startup?
Yeah, absolutely. And what was unique about this plant was where the location is. So there was two options. You know, if you catch it early enough and you really don't want to change your design, I mean, there is benefits on where this blower was located. It could have been located downstream. So instead of me pushing through this whole unit, which had a large pressure drop, it could be relocated right here with the flow control valve. Because it's trying to push it back into your upstream pressure there, so at a higher pressure, so you could relocate it. But also, they didn't actually have to relocate this blower. We could have easily have tied in startup lines. So where this equipment was laid out, we could have had startup lines that could have just been hooked up right here, where we could have had a block valve and we could have provided a suction and a discharge line. So really, it could have just been simple piping mods. It would have been 20 feet of a supply and 20 feet of a return line. It would have been as simple as that if we could have saw that up front. Also, I probably would have argued that you can run a two-stage recip at these lower pressures just because it's for a short period of time. We really don't like to do that because we can damage the valves on the compressors themselves. But again, these dryouts are 2 to 3 days. It's not going to be damaging these valves. We just don't want to do that for long term. So I probably would have argued you don't really need to do it. It is nice to be able to do it, but we had a spaghetti full of piping and a lot of valves, which were gate valves, 12-inch gate valves that have to open and close, even if we wanted to single stage it. Okay, the gap. So the other thing is the alignment. It's the who, the how, and when of commissioning. So what I talked about before and what I saw early on in my career is the EPC contractor gets done with their construction installation, and there's really no communication with the owner operator. What the expectation is, the owner operator saying, okay, these guys are surely they designed this, surely they're going to be sticking around. They're going to be the experts that train us and tell us how we're going to be starting this equipment up. And that usually doesn't happen. They'll bring in vendors that can commission the individual equipment, but integrating all that equipment, you've just brought vendors out to commission to actually start up this plant. There's no plan. There's no task list all the way from going into commissioning and then doing the startup. So that's what we do. We look at it and we want to define the who, the how, and the when. So just high level, just to move this along a little bit. So I'd already talked about the new design build. You know, that's usually pre-execute. You know, late select, early define. And after that, what we really like to do is when we get near the end of the design phase, we're going to start looking at the commissioning and startup plan and what's involved. So what's the when? The when is my detailed commissioning and startup schedule, and I'll show an example of that on the last slide here. The who and the how. But typically when we do commissioning and startups, this is usually the format that we follow. We have the pre-commissioning tasks, and then we provide checklists. So this is our back check to make sure we have all the pre-commissioning tasks done. But we want to define what that is. You know, I preach that for somebody to say they're mechanically complete, they have to have all their pre-commissioning tasks done. Otherwise, I'm not going to say you're mechanically complete. Also mechanically complete, we have checklists for that as well. Typically that's followed with a sign off. A lot of your milestones that, you know, the contractor is going to be getting payment for has to do on their mechanically complete date. So I've had jobs where if this mechanically complete date is done so many weeks in advance from what was originally scheduled, the contractor would get bonuses for it, you know, and vice versa. If they're late, they may be paying penalties for that. Very important to have that defined and defined early on. Commissioning tasks and the startup tasks, we'll look at what's involved with that as well. And again, a lot of people forget about the startup task. It's no different than doing a construction schedule. There's a certain sequence of startups that you have to perform in order to get this done. So won't go through a lot of this. Some of the things I just want to highlight. It's really just showing a timeline. So what our schedule would look like is the pre-commissioning and vendor pre-commissioning. We want to define when the vendor is going to be on site, right? We don't want to bring vendors on site, not be ready. They're on standby time, or you're paying for them to travel back home and then to come back. So again, really want to make sure we define the task, what it takes. You have your mechanically complete. Then you can see here, just to highlight, you have your commissioning. You can see we have commissioning. So we have the activities we can commission before our PSSR. A lot of the times you're not going to be able to commission all this equipment until it's post PSSR. So maybe I need to introduce fuel gas to light a flare. That's an example. Vendor commissioning, a lot of this stuff that you have to wait for startup. Again, I have to introduce gas to the compressors at operating pressures to get my final commissioning pumps. I need to be making liquids or have a liquid product available to do that vendor commissioning. So that's why you see the commissioning is typically broken out in two different locations. And then finally here, the performance testing. And on each one of these, we have the detailed task list. We're defining who's doing that, and exactly when, and you know how long is it going to take. And then again, we're back checking and we have checklists. So we're doing progress tracking. We've got to track everything. Loop checks are always the critical path. I want a daily report on where we're at on loop checks. I mean, if I have 1,000 pieces of instruments, 1,000 loop checks that have to be done, we need to get this done in 2 weeks. I need a daily report on where we're at. I need to know what instruments failed, what needs to be replaced on that. Do I have a bad transmitter? So here's a real life example. You know, usually what we'll see on site when we get involved early, and this is why I say the earlier the better. I may just get a schedule that says you have 2 weeks for commissioning and startup, and that's all it says. That doesn't help anybody out. That's what I'm saying. I have a gap. I'm not defining what needs to be done. So like in this particular time list here, so what some of the things we commonly see missing, PSSRs, everybody seems to forget about this. So in this schedule that we received from the EPC contractor, they're saying, okay, cryo dry out and then cryo start up. There's my milestone. Doesn't work that way. I'm going to have to do my PSSRs, get a lot of equipment ready before I actually do the startup for it. And then we have steps and tasks that are out of order. So again, real life example, if I'm starting up November 22nd, you're going to be bringing a vendor on site to do the refridge unit and get it started up. I can't run that way. I'm going to have a lot of product out of spec if I don't have my refridge unit running the same time as the cryo startup. So we look at this schedule early and say, no, this needs to be bumped up, right? And then the other one is who is responsible. I mean, I can list all these tasks, but who's responsible for doing it? You know, that it's very important to define that. So this just looks like an example of the information we take and what we're trying to produce. So we typically want to produce 3 items there. So we define our project task list. That's early on, right? We want to list the details that we see for these tasks. There may be things that are going to be added or deleted, you know, depending on when we are actually getting further on into the define and execute stage on who's doing what and all the tasks involved. Usually there it's pretty high level. We just want to know the number of days to complete. You know, if I'm doing a bake out, say on a furnace, it's going to take 2-3 days. You know, the vendor will usually tell you what that's going to be. From there, once we have the tasks and the number of days to complete, then we start building what I call our project task list schedule. So that's what this would look like. Maybe a little difficult to see, but and I just took a snapshot here. This was just talking about post PSSR commissioning, PSSR, and startup. And you can see for startup, we do have tasks, and there's a timeline on what's needed. And over here, I have the calendar. So we have our start and our finish dates. So everybody's in line for when I need vendors on site, who's doing what and when, up to and including the startup. It's not just saying cryo startup. There's a lot of things involved for us to say we're started up, and now we can start doing the performance testing. And then finally here, what I will do, because it helps everybody on a high level. So if you're having daily meetings or say weekly meetings just to get updates, depending on how big the project is, for upper management and stuff like that, we'll put a simplified version of this back into a calendar, so that everybody can just say, you can see the milestones and when vendors are on site. So it's kind of taking this, putting these two updates in there, and then finally just basically revising the schedule. So summary, what we provide, the experienced people, we're going to close the gap with the experienced people. We have the knowledge for commissioning and startup, what it takes, a proven design plan for commissioning and startup. And again, the earlier the better. Let's look at what we need. Startup lines. How are we purging this equipment? How are we blowing it down? Are there means to blow this down to a flare? We're talking about hydrocarbons. I don't want to be blowing this down the atmosphere if I can help it. Again, the alignment, that's the who, what, and when. And that's how we're bridging the gap between the owners and the operators. That's it. Thank you. Any questions?